we present an exploration of graphical cues and pre-cues in AR for sequential 6DOF rigid body transformations. A cue indicates the current step to perform, while pre-cues provide information about future steps before the user performs them. Existing work on cueing and pre-cueing sequential rigid body transformations that involve rotation has examined only 1 degree of freedom rotations alone or in conjunction with 3DOF translations. We extend this line of research to address sequential tasks that involve multiple steps. In each step, a user must pick up a physical object, rotate it in 3D while translating it in 3D, and deposit it in a target 6DOF pose. We built a testbed to explore cueing and pre-cueing in such a task and develop and compare 2 types of visualizations. One suggests actions to finish the step, and the other shows the goal of the step. Our action-based Euler visualization shows the rotation in a step using an angle axis representation. It suggests to the user an optimal rotation computed based on Euler's rotation theorem. It uses conjoined cyan and red cylinders superimposed on the task object to display the Euler axis, and a circular arrow to show the required rotation angle in a step. The arrow tail updates to reflect the amount of rotation applied by the user around the Euler axis, while the arrowhead remains fixed relative to the rotation axis. When the user rotates the task object, the axis visualization on the task object is also rotated. We compute the Euler axis only at the beginning of the step, while we continuously update the remaining rotation amount. In contrast to the action-based visualization, our goal-based visualizations focus on explicitly indicating the intended destination and orientation for the user to achieve, rather than the specific action suggested to reach it. Each of our goal-based visualizations has 2 Z shapes, one placed on the task object and another on the destination. The user must align the 2 by translating and rotating the task object. We created 3 versions of goal-based visualization: goal-based Euler, goal and action-based, and goal-based independent. In goal-based Euler, we add an orientation offset to the 2 Z shapes to align them with the Euler axis, computed in the same way as the action-based visualization. We compare this to the action-based Euler visualization to determine whether an implicit hint of the required rotation provided by the Euler axis is more effective than an explicit circular arrow. In goal and action-based, we add the circular arrow in the action-based visualization to the goal-based Euler version. We designed it to test whether the circular arrow improves performance compared to the goal-based Euler version or if it confuses users. In goal-based independent, we do not add an additional orientation offset to the goal-based visualizations. We want to determine whether users can perform better when given a suboptimal orientation compared to the action-based visualization. We conducted a user study to evaluate our visualizations and determine if pre-cues could make users more effective. The results show that participants performed better with goal-based visualizations than with action-based visualizations, and most effectively with the goal-based Euler version. However, only a few participants benefited from pre-cues, most likely because of the cognitive load of 3D rotations. To learn more, please see our paper.